Hello senior one, how are you all? Today I'll talk about types of measurement. Types of measurement classified into direct measurement and indirect measurement. First one, direct measurement. If I wanna measure the density, if I bring a hydrometer, it's a device that's used to measure the density and I put like wire in the hydrometer, I get a number. That number is the density of the wire. So how many times I make to measure the density? It's only just one step because I get the hydrometer and put water and I get finally the number. So the density get in one step. So it's called direct measurement. Okay, for example, if I want to measure the density, as we know, the density equal mass over volume. If I measuring the mass of the wire, then I'm measuring the volume of the wire. Length times length times width times height, and I division the mass over the volume. So how many steps to determine the density in this case? We having many steps. Number one, I calculating the mass using the balance. Number two, I measuring the length times width times height. Then I division the mass over the volume. So the indirect measurement more than one steps. So direct measurement just one step. Indirect just more than one step. Okay, number of measuring tools. Direct measurement, I just using hydrometer to measure the density, so it's just one measuring tool. Indirect, I used the balance for measuring the mass. Then I using, for example, micrometer, meter tape, anything for measuring the length times width times height. So indirect more than one tools. Number of measuring process. The direct process is just one measuring process because I get the hydrometer put inside the water and I'm measuring the density. So it's just one measuring process. Indirect more than one measuring process. Which one of them needing mathematically relation? Direct doesn't need anything. Indirect, when I get the mass and getting the volume, I'm making the relation that density equal mass over volume and division mass over volume. So indirect needing a mathematically relation. Number of errors. Indirect measurement it only one error. When I putting the wire in the hydrometer, just only one, and we have many reasons for this errors. Indirect, maybe I have a mistake in measuring the mass, have a mistake in measuring length or width or height. So the conclusion of direct and indirect. Direct, everything just one. Indirect, more than one. We have some important notes. Number one, to add or subtract two physical quantities, they must be same kind. For example, we can't subtract mass with distance or velocity with energy. We can't add length plus area. Length plus area, it doesn't make any sense. So we can't add two physical quantities and they aren't same kind. Okay. Number two, we can't add or subtracting two physical quantities that having different units. Like what? Like 1 meter plus 170 centimeter. It doesn't make any sense. We must convert one of them to the other unit. Like 1 meter plus 170 centimeter. It's meaning 100 centimeter plus 170 centimeter. So it's equal to 170 centimeter. It's meaning. Okay. Number three, we can multiply or divide two physical quantities of different dimensional formula. In this case, we can obtain new physical quantities like by multiplying mass and the velocity. We can get new physical quantities, which is momentum, and we can divide the distance over time, and we can get new physical quantities is the velocity. Okay. We have many reasons for measurement errors. Number one, choosing unsuitable tools. For example, when I want to measure the mass of a gold, if I get a digital balance or analog balance, it doesn't useful for my gold. So choosing suitable tools for measuring everything. Gold, we must use sensitive balance. Number two, a defect in measuring tools, or the defect that may be in the ammeter. Ammeter is a device that used to measure the current intensity. In some cases, the ammeter having a defect. Okay. Number three, a wrong procedure due to inexperienced persons. We must read any reading in any device with perpendicular plane. Okay. Number four, environmental conditions. For example, temperature and humidity. Temperature increasing the room temperature, and it must it may be make any defects in the device. Estimating the error of measurement. To calculate the error, we have two types. Number one, absolute error and its sample delta x, relative error and its sample r. What the difference between them? Absolute error is defined by the difference between the real value, it's denoted by x naught, and the measured value, it's denoted by x. What the meaning of difference between real value and measured value? When I said my length is 164 centimeters, so its real value, my length is 164 centimeters. When someone is measured me and he said my length is 170, so it's 170 centimeters, so it's measured value. So the real value 164, the measured value 170. So the absolute error, the difference between them, is equal 6 centimeters. So the rule of absolute error, x naught minus x, or x minus x naught, because we just need the error, doesn't need the direction, just only the number of errors. So the absolute error is the difference between the real value and measured value. Of course, having measuring unit, because when I said my length 164 centimeter and the measured is 170 centimeter, so the difference between them is 6 centimeter. Okay. Now I talk about relative error. The relative error is a ratio between the absolute error and the real value. So it's a rule delta x over x naught. For sure, it doesn't have a measuring unit because it's a ratio between two same quantities. When I said delta x equal 6 centimeter over 10 centimeter, centimeter can remove from centimeter, so it's called it doesn't have a measuring unit. Example to test your understanding. A student measured the length of a pencil and he found it equal 9.9 centimeter. Meanwhile, its actual length, so its actual length, it is real value or actual value. When he said a student measured the length, so its measured value equal 9.9. So x equal 9.9, real value equal 10. Okay, so from this we can get absolute error. Absolute error equal x naught minus x. So 10 minus 9.9 is equal 0.1 centimeter. And relative error equal delta x over x naught. As we get delta x equal 0.1 and x naught equal 10. So the ratio between the absolute and real value equal 1%. Okay, this for the first student. For the another student measured the classroom length and he found it equal 9.13 meter. It equal measured value equal x. So the x in the second case equal 9.13 meter. Meanwhile, its actual length equal 9.11. So actual length or real length equal 9.11. So it's x naught. In this case, or in the second students, we can measure or we can calculate the absolute error and the relative error by same way. Absolute error equal delta x equal x naught minus x. As we know, x naught 9.11 and x node x node 9.11 and x 9.13. So the difference between them equals 0.02. So the relative error, absolute error over real value, so its percentage equal 0.22 percentage. When I finished to calculate the absolute and relative error, we must put our solution in the form that delta x node plus or minus delta x. For example, in the first student, x node equal 10 plus or minus delta x equal 0.1. So expressing the result of measurement of the length of the pencil in the form x node plus or minus delta x. Also in the second student, expressing your result the length of the classroom and x node plus or minus delta x, so 9.11 plus or minus 0.02. Okay.